All right, the last problem on this set, problem number 6. A little series, differential equation, stuff mixed in. Again, series problems pretty common. So we got a differential equation, dy dt equals y raised to 6 minus y. We know that the function evaluated at 0 is equal to 8. First question was to sketch. They gave you a slope field. Here's that slope field again. They actually just sketch the graphs, the solutions through the point 0.08. So I think that's that one right there. There's an asymptote there at 6, I think it was. And the 1 through 3, 2 is going to look a little bit like that. Next question, Euler's method. This pops up a lot. It's pretty common. There are only 3 questions. I don't know if it's going to pop up or not. It's a pretty common difference between A, B, and BC, though, again, of course. So a quick review of Euler's method. We're starting with the point 0.08 that we're given. We're trying to find a solution at 1. So we're going with 2 steps. So we're going to take an intermediate step. We're going to stop at 1/2. So you take your old solution, which is the 8. You add to it the step size, which in this case is 1/2 because we're going from 0 to 1 in 2 steps. So 1/2 times, and that -2 comes from taking the point and plugging it back into the derivative. So we're taking 0.8. In this case, it's only y we're concerned about. So 8's going in there. 8 over 8, 6 minus 8 gives me -2, gives me 7. So that's the solution at 1/2. So now I'm at 1/2 7. I'm just going to do that same thing. I'm going to take the 7. I'm going to add to that the step size, which is 1/2. And then I'm going to take the 1/2 7 and plug it into the derivative. Again, I'm only concerned with the 7 because the y, 7 over 8. 6 minus 7 is -1, gives me the -7/8. Add those together, you get 6 and 9/16. So let's see. Next part is write the second degree Taylor polynomial and then use it to approximate f of 1. So again, second degree Taylor polynomial in general is just the function evaluated at 0 plus the first derivative evaluated at 0 times x plus the second derivative evaluated at 0 times x squared over 2 factorial. They gave me the 0. Same process as that other problem where you might go through the derivatives, but I don't need to because I have the value. So f of 0 I know is 8. The derivative at 0, so remember this is the derivative, so at 0, but when x is 0, y is 8, so 8's going to this, just give me the -2, which is right here also. Now I just need the second derivative, so I can plug it in right there. So the second derivative is just derivative of this. It's a product rule, implicit differentiation, so it's y prime over 8, where am I here? Y prime over 8 times the second term 6 minus y minus the derivative of that term, which is a y prime, times the y over 8. And I'm just going to plug in 8 for y, and remember I had a -2 for y prime. So that's going in for y prime, so -2 for y prime, 8 for y, do all that work, and I get the second derivative being 2.5. So that's just going to go in there. So it's the function value 0, which is 8, minus the 2x, the 2 coming from here, and then the 5/2 from here, times x squared over 2 factorial. And then he said use it to approximate f of 1, so I just plugged 1 into that. I got 8 minus 2 plus 5/2, so 29 over 4. Last question, I remember this last question the year this test was given. Everyone didn't like it, no one got it right. It is a hard question, a little tricky for sure. The question was to find the range for when t is greater than 0, and we have the slope field again. I just draw a rough picture of the slope field. So we know the whole key to this problem is we knew this initial condition, that f of 0 equals 8. So what that means is we're looking for the function, but we know the function goes through 0, 8. So that was the picture we drew in the first place. So that means that's my function. Okay, remember there's infinitely many functions here on the slope field, but we're looking for the one function that goes through this point. So that's this function. And the thing was t is greater than 0, this was t. So this graph goes like this, and the range are just the y values. So notice this curve is getting stuck by this asymptote at 6, so the lowest it's ever going to get is 6. And because t is greater than 0, the curve's going here, just sort of stopping right there where y is 8. So it's between y equals 6 and y equals 8. Pretty tricky question on that one for sure. It all boiled down to this curve because you had curves all over the place on that one. So that's it for that set.